Hey guys, and welcome back. This is the third part in the devlog video series where I develop a material editor for my custom game engine. If you haven't watched the previous two parts yet, be sure to do that first so that you know what we're talking about here. So, it's been almost a week now since the first video, and I have been working very hard on finishing the editor part of this project. Essentially finishing up this application that you see in front of you, at least to a state where it can be used to actually generate materials and shaders. And I expect to move on to some fundamental code generation in the next video. But to be able to do that, you need to have a working base editor, and I'm pretty much there right now. So I figured this would be a pretty good place to take a break and show you what I have. So we have a few new UI elements. For example, this render pass property window here that wasn't there in the previous episode. But before we move on to these new things, let's just look at some of the fundamentals first. So one very important thing is that every change to the material is now tracked through the command system. So the command system is the system that allows us to have undo redo support in the engine. And for example, now if we set this to multiply and click undo, you can see that the value goes back to add, and you can also see the editor log here tracking all the commands. So every single change, every movement, every property change, everything is tracked through commands. Even these new properties here are tracked through commands. As you can see, we can undo them like this. This is very important to have, since if you only track certain changes through the command system, it's very easy to end up in a state where the state of the material becomes invalid when you go back in history, because certain things aren't what they should be. If you want to know more about the command system, then I covered it in detail in the previous video, so I won't go into more detail about that now. But suffice to say, I'm pretty happy with the system right now and how it tracks essentially everything you do now. So one thing that you might notice, something that's new in these nodes now, is that they actually have these values here. So this is a floating point operation, for example. So it takes two values in. It has these two input pins here, and it results, it returns or results in another float. And you can actually now set these values here. So we can put this to pi, for example, like this. And you can also connect this value to an input pin. And as we do that, you can see that the value actually disappears. And this is something that I took from Blender. I'm pretty sure some other editors do it as well. But here we have Blender, and we have this connection here. You can see that I put a value there, but as soon as I connect a pin to it, it sort of goes away. So the pin overrides whatever value is given to this. And I wanted the same for this engine. So the ST node editor component that I use for the UI here, it didn't actually support this, so I had to build the system myself. But now you can place a property in a node, and then you can associate it with a pin like this. And that works quite nicely. Another change here is that you may remember that we used to have like a node property window here, where when you selected one of these nodes, its properties came up here. That was my sort of initial thought, that maybe I would want something like that, but I actually disabled it for now. I don't think we need that, because we should be able to just input everything just by actually viewing and clicking and inputting the values here in the view itself, like this. And you can, of course, you can do like validation, value validation here as well. So this expects a floating point, as we can see, and if we just input a text here, it just tells us that it doesn't know how to treat that as a floating point value. So I'm hoping we can make do without the node property window. I also added a system that allows nodes to display warnings or errors to users right here in the view. So if we take a vector operation, for example, like this, let's move these off to the side a little bit, and we can add another one here. So we want to add two vectors together and output the result somewhere. These are now treated as three-dimensional vectors, and that's the default when you add one of these vector operations. But as we discussed previously, these are actually called vector variants, and you can treat them as anything from 1 to 4 dimensions. So we can make this treat these vectors as 2-dimensional vectors like this. But as you actually already saw, if we undo one of these changes here, the node now tells us that the values have different dimensions. So essentially what you're trying to do here now is adding a 2D vector and a 3D vector together, which mathematically isn't possible, but technically is possible now through the type system, because these are still two vector variants like this. So the node just simply tells us that, hey, this might be a problem, and we can then treat this particular case as we can add a 0 as a third component to this one, or something like this. I haven't exactly decided how I want to treat this particular case yet, but I know that some of the shader languages like HLSL and GLSL, they actually allow this kind of thing to happen, and they essentially promote one of the vectors to another in certain cases, not in all cases. So that's pretty cool. And I've also improved these controls a little bit in the nodes. So these are called controls, and they can be essentially compared to normal like Windows Forms controls. You can add buttons, checkboxes, drop downs, or these like input fields, whatever you want to the node. And I improved this a little bit. For example, this drop down now has like a highlight that the original one didn't have. And I'm kind of happy with how the data now flows. If you want to add a new node to the system, it's pretty easy now. So if we look at this VectorOp type, for example, I should be able to find it here. It's in nodes and math and VectorOp node. Let's make the font a bit bigger. So you use this kind of attribute to just declare where in this list it will appear, and you can give it a description. And this is essentially everything you need to do to set up the system. So we have 3 properties. We have the operation, we have the values, and they're declared down here as actual properties. I'll get to this attribute in a bit. And then we, if we look at the node again here at the same time as the code, the ST node editor needs us to actually put 2 empty lines here, which essentially moves these pins down. Otherwise they would appear here and here. That's just the way it handles like actually moving things down. It's a little silly, but it is what it is. Then we add two input pins, which the ST node editor calls options, and an output pin. And then we set up the controls. So here we have select enum box and 2 input boxes. And you essentially you tell it the name of the property that they actually correspond to, and that's all you need to do. Then you just add it to the controls of the node. And it's worth mentioning that almost everything here is actually available to you if you just use the SD node editor library out of the box. Like this logic here that it sort of disables the input here. That's not available, but that's pretty easy to add if you want that. So then we have the actual properties here, and we have a property changed, and this is the logic that for this particular node shows the warning. So if you just put in a 1 here, this gets run and it just checks are the types for value 1 and value 2 different, then it shows the node error, and if they aren't, then it removes them. So you can sort of override the warning logic for each node type, because different things mean different things for different node types. Okay, so then we have these actual properties here and this material node data attribute. So I mentioned in the previous episode that these visual nodes here on the editor, they are not actually what gets saved to disk and loaded from disk. Every time we drag a new node to the editor creates this visual node here, but through a command we actually add a data node as well. And the idea is that the converter that's going to convert this into a shader is not actually going to need to know anything about this SD node component and the visual layout of this. It only needs to know what kind of node is connected to what kind of node and the properties. And so we have another node type, which I think is in float math nodes. Yes. So the idea here is that, actually it was VectorOp node, so we just need to look at that one instead. So we have a VectorOp node in the basis material editor, and there's also a basis material lib, so material library, which doesn't know anything about the actual material editor. It just knows about materials. And using this material library, you should be able to actually create a shader generator of sorts that just takes a node graph of a material without having to know anything about the actual editor, the application, the visual application with the UI and everything. And here we also have a VectorOp node, so it has the same name as this class here. And these two are linked together on the editor side, so whenever we create one of these, we also create one of these in the data flow. And here we can see that it has the same properties as this guy, and they both have this material node data. And that means that whenever we change one of these, it also changes automatically one of these guys in here. So if you change the operation here, it also changes the operation in here. We also have a serialized node data, which just means that this is a node that when we actually store the material to disk, this is something that we want to serialize. So this is actually the first time I've used custom attributes in a C# project or a .NET project like this, and turned out to be a pretty nice way to actually automatically handle all the data conversions and everything. You don't need to tell the system anything about like types or anything like this. It figures it out all on its own. So for example, if we shut this down and exit full screen here, someone might say that there's a little bit of code duplication here, and that's true, but that actually is not that big of a problem, because this class here is actually the one that is important in this case. This is the one that defines what a vector operation in a material node graph is. And this class here knows about this class, but this class has no idea about this class, because the one on the left is only responsible for setting up the UI, and arguably you wouldn't need a UI to create a shader out of this. You could create like a node graph completely through code, for example, and only use these kinds of guys. Anyway, if we forget to add these attributes here, and we try to start the program now, it actually complains about it. So it says that the data node property operation of node type VectorOp node is missing the correct attribute. So it actually knows that, oh, okay, this class here is tied to this class here. Let's make sure they are sort of matching each other, so that you don't get data mismatch errors. I'm not sure if actually showing a message box is the correct and final way to handle that, but for now it's a pretty easy way to let me know that, oh, I missed something. And you can see here that the data node, which is the one on the right, it doesn't have these controls. It doesn't need to know anything about any UI, so it doesn't have these drop-down boxes or whatever. It still has the input and output pins, and they need to match the input and output pins added here. But it doesn't need to know about the controls. It only needs to know the input pins and the properties. And through this we can generate the actual shader editor or a shader generator, and generate like a piece of code out of this that makes sense. We have everything we need right here. So I briefly mentioned this serialized node data, that this is what actually causes this operation to be written to disk. So what does that look like? Let's start the editor again and have a look. So if we drag one of these guys, so we had a VectorOp, I just drag it here, and this is in the opaque pass for the pixel shader stage. So if we save this now and put it to test materials, and let's write test here. So let's go have a look at what it actually wrote. Oh, it's worth mentioning perhaps that the SD node editor also has a way to actually serialize this node graph to disk in binary form. And so if you just want to make a node editor kind of quick and dirty thing, that might be a pretty good way. It's certainly the easiest way to be able to store a graph like this to disk and then read it back in. But in my case, I actually don't store these visual node graphs at all. I recreate them from the data stored in these data nodes, in these guys. So by knowing that one of these guys matches one of these guys, if when loading the material back in, when you encounter a VectorOp node like this, it actually knows, oh, I need to create one of these, and that is how I sort of get this visual representation back. But you can certainly just use the editor directly to store data to disk. But that is in binary form. And now if we look at the basis node material that we created here, and we can edit it, Notepad, for example, you can see that this is in JSON, and I specifically want this in human readable form, so that I tend to want my sort of work files to be in human readable form, so that if something breaks, you can actually go in just using a normal text editor and look at, like, okay, what did it actually save? And we start with the file version of 1. So this is another thing that I tend to write to all of my work files. If I make some structural changes to this format here, I can just up this number and then have a converter that goes through all my materials and upgrade them to the new version. So that's very good to have. So the rest of this file is the material. There's quite a bit of information here, but we only need to concern ourselves with this first render pass here, which is the opaque pass. So you can see here that we're on the opaque pass and we're on the pixel shader stage. So this is the opaque pass. We have some pipeline state data that we'll get to in a bit, and we have a shader graph list. And we actually have two. You can see we have one vertex. It doesn't have any nodes, doesn't have any connections. Well, it's actually here. It's just an empty node graph for now. So that's something that we would need to actually input something. Then we have a pixel shader stage, and here we can see that okay, we actually do have a node here. We don't have any connections yet because we can't connect it to anything. We only have one. And this is now the way that we write these things. So all of that is standard stuff that comes with every node. So you get an ID, you get a node type, both in a sort of short form and in an assembly qualified name, which is like the .NET string that allows it to uniquely identify, okay, this is the kind of node that I need to create when loading this back into memory. And then we just have the metrics, left, top, width, and height. And then these guys here are these three properties. So if we added a fourth one and just put this attribute here, it would automatically get added to the data. So it's quite easy to make changes here. And now if we put another node here, so just do something like this, and we can connect that, and maybe we can add like, I don't know, 1, 2, 3 or something here, and we save this and we go back here, reload it. We can see that okay, we have a new node here. There's the stored properties and the connections from node ID, from pin name, to node ID and to pin name. And using this, we can shut this down. We can open it back up, and we can open up the material, and we get back the graph. And this, of course, works with all of the stages. There's a new window here which I also created, which lets you modify. So here we have all the render passes currently that we can add materials for. And the opaque pass is currently the one that has a node graph. We have a few disabled states, so this material doesn't render transparent objects or distant objects. Distant objects would be things like clouds or well, anything that is like thousands of world units away need to be rendered slightly differently. And then we have some shadow map and AO passes here that are using the default shaders, so to speak. So they're still rendered, but we shouldn't actually write any custom stuff here because they use the default one. And then you have editor gizmos. You can still, if you want to make a custom shader pass, you can still set this to node graph, and then you need to tick, okay, which of the shader stages do you actually want to enable. So if we did that, we were like, okay, we want vertex, we want, I don't know, geometry and pixel, and press OK. Oh, haha, look at this. And we're back. Yeah, sorry about that. I found a bug in my code. So this material properties window is one of the more recent additions to the editor. So that was something that I hadn't accounted for. But yes, if we go back and we set this to node graph, I think we ticked these three. And then now if we go to shadow map, you get these drop downs here, and you can start putting things in the node editor. So as you can see from the warning text here, whenever you actually make any structural changes to to the material through this window, I just clear the undo history. It's essentially me just throwing my hands up and going like, oh, I'm not going to actually deal with that, because it reorganizes almost everything in the material, or it can, depending on what you do. So it's just a warning here that, okay, you can't actually undo past that point. But you shouldn't actually need to make changes to the material very often in here. Like you can add new passes and enable them, and the old ones will still work. You don't lose any data per se. You just lose the ability to go back. And of course, you can also always reload the material. The state might look a little weird here. Like a render pass can be either disabled, which means that it's not used at all, or you can use the default shaders, which means that you don't have any control here in this material, but it will still use default shadow map shaders, for example. The default pass can't be used for every render pass, only the certain ones. And then you have this node graph here, which essentially currently means that it is enabled. It can be edited in the material editor, but I didn't call it enabled. Rather, I called it node graph, because maybe we'll want to actually add support for like handwritten code or something later down the line. And if you want to do something that's tricky to do in a node graph, then that's possible to add support here. Yes. So for a render pass that has the node graph state, you also get to set these pipeline state flags. And these were the same ones that we looked at in Godot previously here. You have things like blend mode, cull mode, some like lighting equations and whatnot. The pipeline state is really the flags that get sent to the graphics API when we're actually creating the pipeline. So we have the cull mode and the fill mode, and whether or not the front is counterclockwise, whether or not to test and write depth, etc. And these are just passed almost like straight through to the graphics API. But we can also add some like lighting equation drop downs and whatnot here if we want to later. There's lots of space. So that's mostly it for now. I think we've covered essentially everything that you can do in the editor right now, and which arguably isn't that much, but that's mostly because we don't really have the node types yet. Like we only have a few ones to like sort of play around with. And so I need to actually start thinking about like, okay, what if we want to make a very basic vertex shader? We want some input nodes and we want some output nodes, and then we want everything in between. And just like in Godot, you need some kind of essentially node which is the type of which is determined by the shader stage, so that you know that okay, this shader stage is actually supposed to output like a color, such as the fragment stage here. So what would the input pins be to that? And that would also mean that depending on which shader stage you are in, some of the nodes here might be unavailable to you. And that's something that I haven't done yet. I'm not filtering this list based on the shader stage or the render pass yet. That's something that I probably want to do, so that you can't accidentally put in the wrong one. Another interesting thing to have a think about is this vertex format here. So this obviously, depending on what format you're using, you get sort of different inputs to the vertex shader stage. So depending on which format you have here, it might perhaps filter this list slightly differently. So this is one really big thing for me to start looking at next, actually adding the nodes that I need to set up a very basic material. And once I have that, I can start actually thinking about code generation, so that we could generate, sort of go from creating a material, setting up the the node graphs and generating an output that the game engine could then render. And if you remember from the first video, that was essentially my goal. I wanted to accomplish that in 2 weeks. So a little over half of that has now gone, and we haven't started on the code generation yet. So maybe we won't make it in 2 weeks, but if that's the case, then it'll take as long as it needs to. Obviously, the whole system won't be done when we get to that point, but that's like the proof of concept stage that I'm gonna try to chronicle through these videos. There are all kinds of other things that still need to be done here on the editor side, like, for example, the ability to just duplicate one of these guys along with all of its values and stuff like that. Maybe add some like groups, things that you can do in Blender, and probably other editors. So lots of things to do still, but I'm thinking this is pretty nice to have this editor already in this shape, where you can add, edit, remove essentially all elements of a material, provided it doesn't crash like it did a moment ago. But yes, as you can see, you're getting these videos sort of very hot off the press, so that's fun. Anyway, I'm gonna end this video now and get back to work essentially. As always, leave a like, subscribe, and comment if you have any comments or questions. I'll be glad to answer them. And I will see you in the next one. Bye.